In this lesson, we're going to focus on the difference between traditional rectangular coordinates, which we have learned about since we began graphing points x, y, and polar coordinates, r theta, which we began learning about this week. We are going to learn about how to convert from one form to the other with their points, and also from one equation to the other. Let's start by learning about the different kinds of formulas that we will use to go back and forth. We learned earlier in trig that r squared is equal to x squared plus y squared, and this is how we are going to take a rectangular point, x comma y, and find the r value for the r theta. We also know that with our basic right triangle trig, that any angle theta can be found by doing tan inverse of y over x. We used this when we were trying to find the directional angle for vectors last chapter. We're going to use the same idea to find our angle theta. We will use the idea that tangent of theta is equal to y over x. So by doing tangent inverse, we can find the angle. We have to recall that the quadrant is important, and we can determine this based on the positive or negativeness of x and y. Now when we are trying to go the other way from a point in polar format into rectangular form, we're going to remember our basic trig definitions. Cosine theta equals x over r, and sine theta equals y over r. Using these definitions, if we solve for x and solve for y, we can find out that x is equal to r cosine theta, and y is equal to r sine theta. So these properties are what we're going to use for all of our equations and our points when we convert back and forth between rectangular and polar. First, let's take a look at an example where we are taking a polar point and converting it into rectangular. We just learned that we can use the formulas x equals r cosine theta and y equals r sine theta to solve for x and y. To solve, we're going to go ahead and say that x is equal to 6 cosine of 7 pi 6. And if we plug in our unit circle value, we know that to be negative root 3 over 2, giving us an x value of negative 3 root 3. Then if we go over here and work on the y side, we can get that y is equal to 6 sine of 7 pi 6. And we can find out that our y value is equal to negative 3. Together, this gives us our ordered pair of negative 3 root 3, comma, negative 3. Going the other way from rectangular into polar, we are going to use our formula that r squared is equal to x squared plus y squared. Now, as you look at this problem, the x and the y values are rather complicated looking, and doing Pythagorean theorem on them is going to be a little bit messy. However, we can handle it. So we'll get r squared equals 49 fourths plus 49 times 3 fourths. And if we go ahead and combine these like terms, we get 196 fourths. Square rooting them gives us that r is equal to 7. Now if we want to go ahead and find our angle, to find our angle we use the idea that theta is equal to tan inverse of y over x. Now before we even go ahead and do our tan inverse, we want to look at the signs of x and y. And we can see that we have a positive x and a negative y, which means that we are in quadrant 4. Based on that, when I get my angle from doing tan inverse, that'll be my reference angle into the 4th quadrant. When I go ahead and look at the ratio of these fractions, I have 7 root 3 over 2 divided by 7 over 2. Now, the 7 over 2 and the 7 over 2 essentially are going to cancel, and the only thing that I am left with is the negative root 3. So I am now doing the tan inverse of negative root 3. And in quadrant 4, we know that to be right around down here. By doing a tan inverse, that answer would give me negative pi thirds. However, we want our answer to be within our first circle, within our 0 to 2 pi. So we add 2 pi to that, and our final answer in polar would be a radius of 7 and an angle of 5 pi thirds. Now, a little shortcut that I'd like to point out to you here. If we look at these x and y values, we can see that the y value is a root 3 multiplier of the x value. And when we are working without a calculator, you know that our triangles are either going to be 30, 60, 90s or 45, 45, 90s. And when you see this, what I would like you to realize is that this is my a and this is my a root 3. Therefore, my r, which is my hypotenuse, is going to be my 2a. And so I can right away figure out that my r is 7 without all of the messy Pythagorean theorem. And then seeing that I have my a root 3, 2a, that tells me that I'm dealing with a 30, 60, 90 triangle. And I could go ahead and I could quickly sketch that out to figure out my angle rather than having to deal with the trig. So for those of you that are good with patterns, this is an alternate way of solving the problem rather than all of the algebra we saw here. Now when we're converting our equations from rectangular into polar form, one of the things that you want to remember is that rectangular forms can only have x's and y's, and polar forms can only have things such as r, theta, and trig functions. If your answer ever happens to have a little bit of both, then you are not done, you have not finished converting. As we are doing our conversions, things that we want to keep in mind are the formulas x squared plus y squared equals r squared, and x equals r cosine theta, and y equals r sine theta. Those are going to be the formulas that we will use to substitute back and forth to convert from rectangular to polar and vice versa. In the first problem, example 3, the only variable that we see here is a y. So we're going to go ahead and use our formula y equals r sine theta and do a substitution for the y. So we'll say r sine theta is equal to negative 3. Now, we like to have our formula solved for a variable. So we're going to solve for r by dividing by sine, giving us r equals negative 3 divided by sine theta. And then finally, if we can write our problem without a fraction, that's even more simplified. So the preferred final answer here would be r equals negative 3 cosecant theta, rewriting that using its reciprocal function. In example 4, we want you to recognize that x squared plus y squared is equal to r squared. So we can quickly go ahead and do a replacement and just say r squared is equal to 81. And if we can square root it, well, that's sure a lot simpler than leaving it the way that it is. So we're going to square root both sides and just say r is equal to plus or minus 9. And this gives us the equation of a circle that has a radius of 9. In example 5, we're going to do two substitutions. On the left, we are going to substitute the x squared plus y squared with an r squared. And on the right, we are going to substitute the y with an r sine theta, giving us r squared equals 8 times r sine theta. From here, we're going to divide both sides by an r, leaving us with r equals 8 sine theta as our final answer. In example 6, before we can go ahead and do any substitutions, we need to first distribute this x minus 7 quantity squared. That gives us x squared minus 14x plus 49. So that's what we get after we distribute. And then plus y squared equals 49. From here, what we're going to do is we're going to take the x squared and the y squared, and we are going to group those together, and we are going to move the other two terms onto the right-hand side, leaving me with x squared plus y squared equals, the 49's cancel off, and then when we minus the 14x over, or rather add the 14x over, it becomes plus 14x. Now we can go ahead and we can replace the x squared plus y squared with r squared, and we can replace the x with r cosine theta, and then just like we saw in example 5, we can divide both sides by an r, and our final answer is r equals 14 cosine theta. Just a quick reminder of techniques that we are allowed to use. We can multiply or divide both sides of an equation by r. We can also square or square root both sides. When we look at the examples on this slide, we'll see both of those techniques. For example 7, we don't have any formulas that just allow us to replace for r. However, we do have a formula that we can replace for r squared. Now, if we were to multiply both sides by r, that wouldn't do us any good because I would have r squared is equal to 6r. So on the left-hand side, it would be useful, but on the right-hand side, it would not. Instead, however, if I square both sides, I still get the r squared on the left, and now I have 36 on the right. And in this way, I am able to get the r squared that I need without getting stuck with a 6r that does not help me. So my final equation, after I do my substitution of x squared plus y squared for r squared, is going to be x squared plus y squared equals 36. For number 8, in this problem what we're looking at is the fact that we just have an angle, and an angle is equal to negative pi 6. What this is going to give us is this is going to give us the equation of a line, and it's going to be the equation of the line that actually goes through the angle of negative pi 6. And negative pi 6 is right there, therefore this is the equation of the line that we are talking about. So if we envision this line, we know that every line is described by its slope and its y-intercept. And this equation is y equals mx plus b. Since the y-intercept is 0, we know that our b is 0. And my slope is going to be equal to the y over x ratio of the triangle that we see here. At negative pi 6, that angle is 30 degrees. Therefore, this is my a, and this is my a root 3. Or I could say that my y is 1, and my x is root 3. And so in this case, my slope is negative 1 over root 3, or negative root 3 over 3. And now that I know my slope, I can go ahead and say that this equation in rectangular form would be y equals negative root 3 over 3x. If I were given a different angle, I would just need to draw the triangle to find the ratio of y to x. In example 9, I have r equals 3 secant theta. Now, I don't have any replacements for secant, however, I do have replacements for cosine. If I divide both sides of my equation by secant theta, I now have r divided by secant theta. And we know that r divided by secant theta is the same as r times cosine theta. And we know that r times cosine theta is equal to x. In our last example, what we look at is the fact that we don't have an r squared or an r sine theta. And for all of our substitutions, we need that. In this case, multiplying both sides by r is more helpful. In example 7, we saw that we needed to square both sides. Here, if I square both sides, that won't do me any good because a sine squared theta is not useful to me. However, if I multiply both sides by r, that then gives me r squared equals 11r sine theta. And now I can do two replacements. On the left, I can replace with x squared plus y squared, and on the right, I can replace with a y. And I now have my equation that is in rectangular form. As you are going through all of these concepts and skills, you want to keep on remembering those formulas that we started out with in the very beginning. X squared plus y squared equals r squared. X equals r cosine theta. Y equals r sine theta. And that theta is equal to tangent inverse of y over x. In all cases, if the formula that you are starting with does not readily substitute, then ideas that we can do are multiply or divide both sides of the equation by r. We can square or square root both sides of the equation, and if that still doesn't get us to where we need to be, then just try other general rules of algebra, such as foiling and moving things to other sides to see if you can get them to simplify. Good luck!